Hello children, the topic that we are going to discuss is inverse trigonometric functions. So let us start with the definition of inverse functions. So as we know that if we have a function f, then inverse of that function f is denoted by this, okay? And inverse of this function f exists if and only if f is 1, 1 as well as onto, okay? But there are many functions which are not 1, 1, onto or both, and hence we cannot talk of the inverses. So if we have a function which is not 1, 1 and onto, then we cannot have inverse of that function. And we know that trigonometric functions are not 1, 1 and onto over the natural domains and in this, and hence the inverses do not exist. Okay, so let us try how we can have inverse trigonometric functions. Okay, so if we could restrict the domain, then it's possible for us to get inverse trigonometric functions. So let us try to understand how we can do that. So the things would be much easier if we include graphs. Okay, so let us start with sine. So here you can see this is the graph of sine function. So here domain is R, okay? So here domain is your x-axis, okay? And here codomain is this closed interval from -1, 1, okay? Even this is range also, and this is your y-axis, okay? So from the graph, it is clear that the function, the given function here, this is onto, but this is not 1, 1. The reason is on the x-axis we can have infinite numbers, okay, for which the images will be same. Like here, if you consider 0, pi, 2 pi, okay, minus pi, minus 2 pi, and so on, you would see that images of these elements is coming to 0. So clearly this function is not 1, 1. Clear? So if this is not 1, 1, then we cannot have inverse of this function. So what is that other way to get an inverse of this function? So what we can do is, if we restrict the domain, okay, so here right now domain, natural domain is real number, but what we would do is we would restrict the domain, okay? So we would exclude some portion of this on this x-axis. So if we consider only this interval, from minus pi by 2 to pi by 2, so here you can see from this point, okay, till this point, in between here you cannot find any two elements, okay, any two element for which images are same. Yes, so clearly for if we define sine for this, from this interval, okay, to this close interval -1, 1, then we would get a 1, 1 as well as onto function. And once we could define 1, 1 as well as onto function, then we can have inverse of that function also, okay? So sine function on restricted domain, okay, so here we have defined this. Clear? So inverse of this will be given as this, okay? Now let us move on to the next. So here now we have graph of cos, okay? So here we can see that domain is the set of real numbers, and here your codomain is the closed interval -1, 1. This is the range also, if you could see in the graph, okay? So here this function is 1, 1 onto, but this is not 1, 1. Again, the reason is same. On the x-axis you could see them you could see many elements for which images are same. Okay, like if you take this 0, 2 pi, minus 2 pi. Okay, so cos 0 is 1, cos 2 pi is also 1, cos minus 2 pi is also 1. So you could see there are many for many elements on this x-axis have the same image. Okay, so clearly this is not 1 1. But if I restrict the domain, okay, if I restrict the domain, that means if I consider this, if I define this function cos for small interval, okay, for where we could make this 1 1. So here if I consider this interval from 0 to pi, okay, so here you can see from 0 till pi, okay, in between you cannot find any two elements for which images are same. Okay, so clearly if I define cos for from this interval 0 comma pi to this, okay, then this function would be 1 1 as well as on 2, and therefore cosine function on restricted domain is given as this. Okay, and then inverse function will be this. Okay, now next is tan. So this is how we define the tan. Okay, and this is the graph of the function, trigonometric function tan. Okay, now again this is on 2. Okay, here codomain is R as well as range is R. Okay, but this is not 1 1. Again the reason is same. On the x-axis you can find many elements for which images are coming to same. Okay, so like here 0 0 0 0. So here tan 0 is also 0. Okay, tan pi is also 0, tan 2 pi is also 0, tan minus pi is also 0. So you could see there are many elements for which images same. Okay, so in that way this is not 1 1. So we, if you have to define if you have then we cannot have inverse of this function. Okay, but if we restrict the domain, okay, if we restrict the domain, then we can have a 1 1 as well as onto function, and we can find an inverse of it. So like here if I restrict this function for this interval, okay, where I'm not including minus pi by 2 and I'm not including this pi by 2 also. Okay, so then you could see here any elements lying between this, we are excluding minus pi by 2 and pi by 2. So we cannot find any two element for which image is same. Okay, so tangent function on restricted domain is this. Okay, this is open bracket because minus pi by 2 and pi by 2 they are not included. Okay, so now this is 1 1 as well as on 2, so we can have inverse function, and this is the inverse function. Clear? Next is, okay, now we move on to cot. So this is how we define the cot function, and this is the graph for that cot. And this defined function graph is here. Okay, again this is on 2, but this is not 1. Clearly you can see. Okay, for this element over here, for this, okay, images are same. In fact, you would find many other points for which images are same. Okay, like if you try to understand here, now see, So you can find many numbers on the x-axis for which images are coming same, like here this point, this point, this point. Okay, images same. Okay, so again this is not 1 1, so we cannot have inverse function of this. Okay, so but if we restrict the domain, okay, if we restrict the domain, then we can get 1 1 as well as onto. So here we can restrict this function on this domain where 0 and pi is excluded. Okay, so we are taking an interval, open interval 0 comma pi. Okay, so this is, we are taking the domain 0 comma pi, the close open interval. So now if you see, you cannot find any two element in between these two. Okay, 0 and pi, for which image is same. Okay, so if we restrict the domain for this open interval 0 comma pi, then this function called will become 1 1 as well as onto. Okay, so in that case we can get an inverse. Next, sec. So this is how it is defined, and this is the graph. So again this is this function is onto, but this is not 1 1. Okay, because again you can see over here, we can see that these 2 points, will have same image. Yes, same way if I consider this, these 2 points will have same image. So on the x-axis you can find two or more than two elements for which images are coming same. So that way this function is not 1 1. So we cannot have inverse. Okay, so we have to restrict its domain in order to get inverse. So here what we can do is we can restrict the domain, and we can take this, we can take domain to be close interval 0 comma pi, and we can exclude pi by 2 from there, because you can see in the graph for pi by 2 your sec is not defined. Okay, so we cannot have this pi by 2 in the domain. So if we restrict the domain for this close interval 0 comma pi, from where pi by 2 is excluded, okay, then the function that we will obtain will be 1 1 as well as onto, and hence we can have inverse, and this is how inverse is given. Okay, next is cosec. So cosec is given as this, and this is the graph of that cosec. So again we can see that this is onto but not 1 1, and you can clearly see that you can find two or more than two elements for which images are same. Okay, like here, this point where the arrow is touching on the x-axis, and this point. So both the points have same image. Okay, so here also you can see these two points will have same image. Same image. Okay, in fact these 4 points, 1 2 3 4, these 4 will have same image. So clearly this is not 1 1. So if it is not 1 1, then we cannot talk about the inverse of this function. But if we restrict the domain, okay, if we restrict the domain, in that case we can get an inverse of that function. Okay, so suppose we restrict this domain, and we consider the domain to be the closed interval minus pi by 2 comma pi by 2, and we exclude the 0, okay, from this closed interval, because you can see for 0 this cosec is not defined, so we cannot have 0 in the domain. Okay, so if we restrict the domain for this minus pi by 2 comma pi by 2, then we can see that this function that will obtain will be 1 1 as well as on 2. Hence we can have an inverse of this. So inverse will be given as this. Okay, now so thus we saw that the restrictions on domains and ranges of trigonometric functions ensure the existence of their inverses, and it's clear through the graphical representation. Okay, and this is the table, okay, which includes the inverse trigonometric function. Here it's written principal value branches. The inverse trigonometric function principal value branches along with their domains and range. So domain is the first set, okay, range is the second one. So in symbol we write this way, okay, or you can write in this manner also, no problem, you can write in this way also. Now the thing is, what is principal value branches? Okay, why do we call this principal value branches? So the answer to this is here. From the graph we can get this answer. Here we saw that, let us try to understand from sign only. Like here we had got this function sine from set of real numbers to this closed interval minus 1 comma 1. Clearly this is not 1 1. This is onto but not 1 1. Now so in order to get inverse, what we had done is we have restricted the domain. Okay, we have restricted the domain, then we have defined this function. Okay, then we could write the inverse of this function. So the thing is, we have done the restriction here, okay, but we could have restricted the domain for this also. Okay, instead of taking minus pi by 2 comma pi by 2, we could have taken pi by 2 comma 3 pi by 2 also. Okay, or we could have taken this interval also. Okay, or we could have taken this interval also. Clear? Or we could have taken this interval also. So if you observe one thing over here is, you can get infinitely many 1 1 onto functions if you restrict the domain. Okay, if you restrict the domain, then you can get many functions 1 1 onto. Okay, but and those function will be 1 1 and onto, so you can get inverse also. But the function which is defined for this restricted domain, okay, for that inverse function will have range as this. Okay, so if we have sine inverse, okay, whose range is this closed interval, okay, then this is called principal value branch. Okay, same way for here also. Okay, we have restricted for this 0 comma pi. We could have done for this also. We could have done for this also. So in that way we could have got many functions which would have been 1 1 as well as 1 2. Okay, but the function which we will define for this interval 0 comma pi, okay, for that inverse will be this, where the range will be 0 comma pi. So if we have a cos inverse whose range is this 0 comma pi, close interval 0 comma pi, then that function, trigonometric function, inverse trigonometric function of cos will be called principal value branch. So here whatever I have discussed, okay, all are principal value branches. Okay, so sometimes in question it's not mentioned. Okay, so even if it's not mentioned, you will consider this principal value branches only. Okay, so okay, now next is, you must note that if it's written sine inverse x, then you should not think that this means sine x the whole power minus 1. Okay, here sine inverse x means here it's denoting the function, okay, inverse function, and sine x to the whole power minus 1 means 1 by sine x. So you should not be confused with this. You must not think that sine inverse x is equal to this. Okay, okay, next, whenever no branch of inverse trigonometric function is mentioned, we mean the principal value branch of the function. Third, the value of an inverse trigonometric functions which lies in the range of principal branch is called the principal value of that inverse trigonometric functions. Okay, so this much for today.